In this set of lectures, we're going to discuss the spinal cord. We'll talk about some of the basic gross anatomy of the spinal cord, its functions. We'll talk about the white matter versus the gray matter, what their functions are, and we'll talk about the peripheral nervous system. So the basic stuff about the spinal cord that is really important to know are that the spinal cord relays sensory information from the periphery, that means your surface, to your brain. And that is both somatic sensory information and visceral information, so your surface and your internal organs. The spinal cord contains motor neurons, and those motor neurons then project out to your muscles, and that means your somatic muscles, your skeletal muscles that move you around, as well as the visceral or smooth muscle of your organs. So within the spinal cord, there are direct or local connections between motor and sensory information, and this interchange of information is responsible for your reflexes. So in addition then to being a sensory relay, it is also, your spinal cord is also a motor relay in that it contains the motor neurons that are going to receive information from your brain and then carry that or relay that information to your muscles, both somatic, i.e. your skeletal muscle, and your hollow organs or your visceral. So the basic setup of your spinal cord is gray matter and white matter, and as you recall, your gray matter is where the neuronal cell bodies live and their proximal dendrites, and the white matter is where the myelinated fiber tracts are. And so on this image, this is the gray matter, and we call it in the spinal cord, we call it our gray butterfly. And you can see it on this image of a real spinal cord that's been kind of magnified, because your spinal cord really is only about the size of your thumb. It's not really that big, which is kind of amazing for what it does. And here's the gray matter. And then out in this area is the white matter. And that is white, again, because it's myelinated, and so it contains quite a bit of lipid, and that looks white in a gross preparation. So the spinal cord has 5 different regions and 2 enlargements. So the regions are cervical, in this zone, thoracic, around in here, lumbar, and then sacral and coccygeal, just way down at the bottom. You have 2 enlargements. There's a cervical enlargement, and that innervates your arm. And it's an enlargement because you have a lot more neurons there, because you have a lot more muscles in your arm, so you need more neurons to innervate them. You also have a lumbar enlargement, which is down here, and that innervates your leg or your lower extremity. So this slide has representations of each of those spinal cord levels. The cervical, lots and lots of white matter, not quite as much gray matter as you'll see as you progress down the cord, but a little bit of that cervical enlargement here because it's going to innervate your upper extremity. In the thoracic region, you know you're in the thoracic cord when you see this little bump here. This is called, I'm just going to abbreviate it for now, and we'll talk a lot more about this when we talk about autonomics, but this is your IML, which is short for intermediolateral cell column, and that's a big mouthful. But this is where, when we talk about the difference between somatic and visceral, this is where those neurons that innervate your hollow organs live, in this little bump here. As you go down, here's the lumbar. Oh, I'm sorry, let's see. This is thoracic, lumbar, and this is the sacral region. I want to take just a minute to explain the difference. You're going to notice if you look at this like, oh my goodness, there's a whole bunch of gray matter and not very much white matter down here, and then there's a whole bunch of white matter and not very much gray matter up here. It's kind of the analogy I use, and this may or may not work for you, but think about it, is a bus route. So if the school is your brain and the bus route represents kind of your spinal cord, if everybody starts at the brain, also all of the nerve fibers that are going to innervate your entire spinal cord start at the top, and as they go down, they exit. So the spinal cord, the fibers that are going to innervate your arm leave, then the spinal cord fibers that are going to innervate your thorax leave, and so by the time you get to the sacrum, you have very few fibers left, right? So all the kids get off the bus on the bus route until there's hardly anybody left. So you have fibers exiting at every level, so that by the time you get to the bottom, you have less white matter. It also works on the way up. So sensory information coming in starts to accumulate. So you get more kids on the bus at the very beginning of the route, which is way out in the boonies. A few kids get on the bus, a few fibers join the spinal cord, and then as you go up, more and more and more fibers join, or more kids are on the bus until you get to the top. And again, everybody's on the bus right before you get to school. So that is kind of my analogy of why you have varying amounts of white matter up and down the cord. So lots of fibers at the top because everybody that's coming in is there and everybody that is going to exit has begun. And then as fibers leave, you diminish as you go down, and as fibers come in, you add as you go up. So that accumulation of adding and subtracting is the net result is fewer fibers in the bottom and more fibers as you get to the top. So in the next segment, we're going to talk a little bit more about the spinal cord and the meninges that cover it.